Okay, welcome back. So now what we're going to do is we're going to go on and introduce some other things that we want to pay attention to. And so in determining end behavior, one of the things we want to look at is how the graph behaves, right? So again, end behavior means it's x gets really big negative and really big positive. What's going on with the graph of the polynomial? So one of the things to understand is if we look at the polynomial, just look at a general polynomial here. We're talking about x values, right? So just ignore the coefficients for a moment, okay? And look at the x values, right? So we've got this constant, we've got this here x, all the way to x to the n minus 1 and x. So what's going on? If we look at each of these terms separately, as x is getting really big, what's going on? Well, this isn't changing. This is growing linearly. X squared is growing exponentially, right? And then so on and so forth. But what do we know about powers? We know that powers grow much faster. Like for example, this doesn't grow at all. This is going to grow linearly. X squared grows, like I said, exponentially. You know, x cubed, right? So x cubed is going to grow faster than x squared. X to the fourth is going to grow faster than x cubed, all the way down to x to the nth power, right? So if x is getting really, really, really big, right? Or whether either positive or negative, right? The end behavior is ultimately going to be controlled by which term? This term, right? The leading term. So if we want to get an idea of what's going on with end behavior, we can ignore all of the terms and focus on the leading term. And this is where we get to what's called the leading term test. Okay? So here are a couple of takeaways when you're looking at the leading term that will tell you what the end behavior of the graph of the polynomial function will look like. So here's one. If n is greater than 0, right? Because if it's 0, then we just have a constant function, which doesn't help us. So if n is greater than 0, as n increases, the graph of the function becomes flatter near the x-intercept. So for example, if we take x squared, okay, our parabola, okay, so let's say we have our parabola. Well, what if we do x to the fourth? Well, what we're going to happen is it'll get narrower here. Oops. It's going to become more of like a cup shape. Oh, let me just erase it this way. What will happen is it becomes narrower on the edges, but it becomes flatter here. So it might do something like that. And then if we go x to the sixth, it'll even get narrower, right? And flatter. So it might do something like this, right? I'm just going to exaggerate it. So it'll go down here, flat, and then come back up. So the higher the exponent, the flatter it gets as you get closer to the x-intercept. So that's what this first statement is saying. Okay, now what about the other two statements? The other two statements are directly related to end behavior, right? So the first statement is about, hey, what happens as you get close to the x-intercept? Okay, so what the first statement is saying is as n increases, it becomes flatter as you get closer to the x-intercept. Likewise, also if I did, let's say, x cubed, right? So if I did f of x equals x cubed, we know that what that looks like, right? So that looks something like that. But what if I did x to the fifth? Same thing. It'll have the same general shape, but what's going to happen is it's going to, again, this is not pretty, but it's going to look something like this. Right, where it flattens out. Okay, so that's statement number one. Statement number two says, oops, not in, if n is even, so if the degree of the polynomial is even, then end behavior of the graph goes in the same direction, okay? Which means the graph is either going to go up in both ends, or they're both going to go down in both ends, regardless of what might be going on in between. Okay? If the degree is odd, so if n is odd, the end behavior goes of the graph, the end behavior goes in opposite directions. So it'll either from left to right, we're always talking about when we read a graph, left to right. So it'll either do something like this, or it'll do something like this. So again, whatever is going on in between, we don't know. But what we do know is as we get further and further to the left or the right, again, as x goes to positive and negative infinity, this is the behavior that we would that we can see. So again, if n is even, if the degree is even, then the end behavior, the tails of the graph, will go in the same direction. If the degree of the polynomial, or if n is odd, then the end behavior is going to be going in opposite directions. All right. And that is what the leading term test will tell us.